On the 25th of July, 1610, Galileo Galilei rushed off a series of letters to a number of his friends and colleagues, announcing, well, that, to a befuddled circle of eyes. If you're puzzled, don't worry. You're supposed to be. It was common practice at the time for scientists to announce major discoveries in nonsense Latin anagrams, allowing them to maintain secrecy until the results were published, and yet also assert their credit should they be inadvertently scooped. People being what they are, Galileo's acquaintances immediately set about trying to crack the anagram to learn what he'd found out. One such colleague was a wild-minded mystical revolutionary named Johannes Kepler. Kepler was one of those fascinating, baroquely brilliant minds that found unique home in the Renaissance. Like Galileo, he was a fervent believer in heliocentrism, though he maintained his assertion largely for astrological and numerological reasons. Despite this, his belief would eventually lead him to construct the most accurate model of planetary orbits ever devised, in which he showed, beyond any reasonable doubt, that the orbits of the planets are elliptical, not circular, and that their orbital speeds increased in proportion to their distance from the Sun, paving the way for Isaac Newton. It also led him to compose the first ever work of space travel fiction, a distorted retelling of which nearly got his mother burned for witchcraft. Such was the time. In keeping with his numerological obsessions, Kepler read Galileo's cryptogram as, quote, Salva, umbistenium yeminatum martia proles, unquote, which translates, rather hilariously, as, quote, Be greeted, double knob, children of Mars, unquote. That is, assuming you accept the word umbistenium, which is really just dog Latin, but whatever. You see, Kepler believed that the solar system's numbers should make sense, and since the Earth had 1 moon, and Jupiter 4, it stood to reason that Mars should have 2. Obviously, that was what his friend Galileo must have discovered. It wasn't, not even remotely, but because maddening coincidences are a theme in solar system discovery, Mars would eventually be found to have 2 moons. In 1877. What Galileo's anagram actually decoded to was, quote, Altissimum planetam tergeminum observavi, unquote, which means, quote, I have observed the highest planet triple, unquote, presumably with an implied to be in front of triple. By the highest planet, Galileo meant Saturn, the farthest known planet from the Sun in his day. Galileo elaborated on what he had seen in letters to his various patrons. To the Grand Duke of Tuscany he wrote, quote, The planet Saturn is not one alone, but is composed of 3, which almost touch one another, and never move nor change with respect to one another. They are arranged in a line parallel to the zodiac, and the middle one is about 3 times the size of the lateral ones. To Giuliano de' Medici he wrote, quote, So, we have found the court of Jupiter, and the 2 servants for this old man, who help him walk and never leave his side, echoing Saturn's mythic role as the ruler of old age. What mystified Galileo was that these things he was seeing around Saturn through his crudely made telescope made no attempt to move around it, but instead remained locked in place, as if they were attached to their planet by cosmic glue. And then, 2 years later, they disappeared. Galileo's reaction was a combination of shock and admirable self-criticism. Quote, What is to be said concerning so strange a metamorphosis? Are the 2 lesser stars consumed after the manner of the solar spots? Has Saturn, perhaps, devoured his own children? Or were the appearances indeed illusion or fraud, with which the glasses have so long deceived me, as well as many others to whom I have shown them? I do not know what to say in a case so surprising, so unlooked for, and so novel. Unquote. By devouring his children, Galileo was referring again to mythology, as the Greek god Kronos, called Saturn by the Romans, ate his own children to prevent them from usurping him. Saturn's slow orbit meant that observations stretched over decades. As resolution improved, Saturn's 2 attendants revealed themselves in more detail, and, despite Galileo memorably once referring to them as ears, began to be seen as ansae, or handles, attached to its side. Ansae would become a standard name for these objects until well into the 19th century. In 1655, after discovering Saturn's moon Titan, Christian Huygens turned his eye to the problem of the handles, believing that Titan had opened the way to solving them. Thanks to his high-resolution telescope, he realized that Saturn was, as he wrote in his own anagram, or annuto cingitur tenui plano nusquam coherente eclipticam inclinato, unquote, which means surrounded by a thin flat ring, nowhere touching, and inclined to the ecliptic. About as succinct a description of reality as you could get. The ring's sudden disappearances were merely due to its tilt relative to the Earth. Usually the ring lay above or below the Earth, revealed in all its splendor. Occasionally, however, it was seen edge-on, rendering it effectively invisible from any telescope of the time. To support his thesis, Huygens made the prediction that the handles would reappear in April of 1656. He was wrong, though they did reappear in October. Initial reaction to Huygens' idea was largely negative. His friends and colleagues were skeptical, and Leopoldo de' Medici, to whom his book was dedicated, failed to respond. Those who had proposed alternate explanations for the handles attacked Huygens with polemical pamphlets accusing him of lying and fraud. Leopold, conversely, congratulated the anonymous author of one pamphlet, saying he would suspend judgment until evidence for the alternate hypotheses could be found. That, Huygens caustically opined, might take a long time. Thankfully, Huygens' persecution was short-lived. By 1661, even his most ardent critics began to grudgingly accept the reality of his ring. But the question remained, what was it? In an age before gravity, no one could formulate an adequate explanation. Some suspected it was some kind of emanation from Saturn's surface, whilst the Vatican librarian, Leo Aletius, memorably speculated that they may have been the wholly circumcised foreskin of Jesus Christ, which had ascended separately the same day he did. The next phase in the discovery of Saturn was led by Giovanni Domenico Cassini. Whilst a professor of astronomy at Bologna, Cassini discovered the rotations of Mars and Jupiter, identified their surface features, and mapped the motions of the Galilean moons. In 1669, he was invited by Louis XIV to head the new Paris Observatory, where, over the next decade, he would discover 4 new moons of Saturn. But perhaps his most celebrated discovery occurred in 1675, when he identified what looked like a broad gap just off the center of Saturn's ring. Today, this gap is known as the Cassini division. In 1714, Jacques Maraldi noticed that the ring, now rings, appeared to be of varying thickness, as one side appeared larger than the other. More than that, he noticed that the larger end reappeared on the other side of Saturn, showing that the rings orbited the planet. He therefore concluded that the rings had to be solid. However, Cassini and his son Jacques, who succeeded him at the observatory, both concluded that this was unlikely. If the rings were solid, then the outermost region would orbit more quickly than the innermost region, as happens with a vinyl record. But observations suggested that the inner part of the ring orbited more quickly than the outer part, or at the very least the same speed, meaning it had to be made of independently orbiting particles. However, belief in the solidity of the ring would last until well into the 19th century. In 1789, William Herschel, discoverer of the planet Uranus and arguably the greatest astronomer of the 18th century, turned his attention to the rings of Saturn. He confirmed that the Cassini division was a gap, rather than simply a dark band, and that, comparing the thickness of the rings to the thickness of the satellites, that they could not have been thicker than 300 miles, a prediction that, rather unusually for him, was far too conservative. The rings were proving a hard horse to break. Many attempts were made to discern finer divisions within them, and some, particularly those observed by Johann Franz Encke, the head of the Berlin Observatory, whose back Urbain Le Verrier would brazenly zip behind in his haste to find Neptune, were even observed by others, but none were considered permanent. Other future Neptune hunters swept up in the search for divisions in the rings included James Challis of Cambridge University, who would be unfairly tarred for centuries as the man who lost Neptune for Britain, and William Lassell, a brewer and amateur astronomer, who would go on to discover Neptune's moon Triton. But the honor of furthering the mystery of Saturn's rings would ultimately fall to neither of them, but rather to 2 fellows named Bond, one British, one American, who in 1850 both independently observed a dark diaphanous extension to the innermost ring that Lassell described as, quote, like a CREP veil covering part of the sky, thus earning its nickname, the CREP ring. The name CREP ring would eventually fall out of fashion, and the more systematic convention of listing the rings alphabetically in order of discovery, as A, B, and C, eventually won out. In 1863, Saturn's sphere was seen behind the C ring, confirming its ephemeral nature, while Lassell also observed it through the Cassini division. Interestingly, the astronomer who proposed the ABC naming convention was named Otto Struve, and his grandson, also named Otto Struve, would become one of the primary inspirations behind the search for extraterrestrial intelligence. In 1850, French astronomer Edouard Roche ran several calculations that suggested that the rings could have formed from tidal disruption of a small moon that came too close to Saturn. Saturn, like its moons, is very near the density of water, somewhat less in fact, and would float given an ocean big enough. And when Roche ran his calculations, he found that if a planet and a satellite were of similar densities, then the satellite could not be closer to the planet than 2.44 planetary radii. Otherwise, tidal force, the same force that the moon exerts over our oceans, would tear the satellite to pieces. The outer limit of the rings lay 2.3 Saturn radii from the planet's cloud tops. Roche's idea remains one of the leading hypotheses for the formation of the rings, and the gravitational boundary beyond which a satellite or planet faces destruction is now known as the Roche limit. In his book, The Demon-Haunted World, Carl Sagan responded to a question frequently posed to the scientifically minded by the not. Why spend so much of our money on science with no applications? Why not just focus on the science that leads to technology? His counter was a thought experiment. Could Queen Victoria, whose coronation coincided with the rise of the telegraph, have, at the start of her reign, successfully funded a program to invent the television? The answer, flatly, is no, because the underlying equations that would eventually allow television to be developed, the inapplicable science, as it were, hadn't been devised. Science must be pure before it can be applied. The man who would ultimately crack the necessary equations, and in the process unify electromagnetism and light, was James Clerk Maxwell, widely regarded as the most important physicist between Newton and Einstein. And it was he who, a few years before developing the physics allowing me to talk to you right now, finally nailed down the true nature of the rings of Saturn. In his 1856 paper On the Stability of the Motions of Saturn's Rings, Maxwell thoroughly and systematically demolished every previous argument regarding their structure and form. If they were solid, either a single sheet or a multitude of concentric rings, then they would be subject to creeping waves of instability that would tear them apart. If they were liquid, then they would eventually be broken up into liquid satellites by those same waves. He finally concluded that, quote, "The only system of rings which can exist is one composed of an indefinite number of unconnected particles, revolving around the planet with different velocities according to their respective distances." Unquote. History, and the space program, would ultimately prove him right. In 1895, American astronomer James Edward Keeler, who most likely was the first person to observe what we now call the Encke division in Saturn's rings in 1888, employed the newly invented spectrograph and the Doppler effect to show that the innermost rings were indeed orbiting more quickly than the outermost rings, finally confirming Maxwell's model. Saturn, effectively, was a world with 1,000,000 moons. In 1866, an American astronomer named Daniel Kirkwood noticed something rather odd about the asteroids being discovered in increasing numbers between Mars and Jupiter. Even though less than 100 were known at the time, he was able to see that they appeared to fall into specific regions, separated by narrow bands containing nothing at all. The gaps coincided with precise ratios of the orbit of Jupiter. For instance, there were no asteroids at the precise distance from the Sun, equivalent to 3 orbits for every one Jupiter orbit. The same was true for the 5:2 ratio, 7:3, and 2:1. Kirkwood realized that these precise orbital ratios would give an additional kick to Jupiter's gravity, akin to being pushed on a swing at just the right moment to go higher. Any asteroid caught in such an unfortunate situation would soon be yanked by Jupiter into a higher orbit, or knocked out of the asteroid belt entirely. As the number of known asteroids increased, so these gaps became ever more pronounced and today are known as the Kirkwood gaps. The following year, in 1867, Kirkwood pondered whether the same logic held for the rings of Saturn. They were, after all, essentially an asteroid belt in miniature, and the many moons in orbit around Saturn could act as little Jupiters in their own right. Specifically, he noted that the Cassini division, the only gap in the rings known at the time, coincided with the precise 2:1 ratio with the tiny moon Mimas. At this point, you might well be saying, all this is well and good, but what does this have to do with water? For a video in the Universe of Water series, this has been fairly dry so far. But discoveries about the rings of Saturn do not come easily from the ground, and it would be decades before anyone would venture to guess what they were made of. One of the first to do so was a man widely regarded as the greatest planetary astronomer of the 20th century, Gerard Kuiper. The singular irony of Gerard Kuiper's life is that one of the few accomplishments of note for which he cannot be credited was predicting the region of the solar system now named after him. His was just one of a number of wildly inaccurate stabs in the dark regarding the then completely unknown outermost part of the solar system mentioned in the paper that did predict it. But Kuiper belt sounds cooler than Fernandez belt, so that's what won out. What did Kuiper discover? 2 moons, one of Neptune and one of Uranus, the atmosphere of Saturn's moon Titan, the landing sites for the Apollo program, the composition of the atmosphere of Mars, and the fact that Mars's polar caps were largely made of water. It was this fact that led Kuiper, in 1948, to speculate that Saturn's rings might also be primarily composed of water, since their spectra were very much the same. Isaac Asimov certainly took this idea to heart, since 4 years later he wrote an Expanse-style short story about independent-minded Martian colonists mining the rings of Saturn for water. Seriously, check it out, it's great. The main problem with checking for water elsewhere in the universe is that there's a lot of water in Earth's atmosphere, which, to be fair, is a good thing for us, if not for astronomy. By the 1970s, telescopes had improved to the extent that the fact that the rings were made of ice was no longer much in dispute. But by then, we had already moved on to phase 2 in our relationship with Saturn. Let's be honest, telescopes are pretty boring. I mean, sure, they'll do in a pinch, but most of the time all they'll tell you is that something's there. Maybe you'll get an idea of how big it is, and if you can catch a decent spectrograph, what it's made of, but all that troublesome distance, to say nothing of the seething, damp atmosphere in the way, means telescopes are never going to give you the full picture. For that, you're going to have to go there. And by the 1970s, we were finally ready to go to Saturn, thanks to hard graft, know-how, and a once-in-150-years planetary alignment. The Voyager Program is the single most successful space mission humanity has ever undertaken. First approved in 1969, it is still ongoing today, with its star probes, Voyager 1 and Voyager 2, returning priceless information from the edge of interstellar space. The Voyager fleet, comprising not only the Voyagers themselves, but also their more primitive trailblazers Pioneer 10 and Pioneer 11, would together revolutionize our understanding of the outer planets, and Saturn's rings along with them. The first thing that the probes revealed was just how many rings Saturn possessed. Alongside the bright A and B rings, and dim inner C ring, the Pioneers and the Voyagers found the nearly invisible D ring inside the C ring, the strangely twisted and braided F ring, and the ghostly outermost G and E rings. But even within the rings themselves, multiple ringlets could be seen, giving them the appearance of a vinyl record. And while numerous gaps were found, the largest, the Cassini division, was shown to be less a gap than home to its own set of dark ringlets, making it essentially another C ring. Radio measurements suggested that the particles ranged from about the size of sand to about the size of houses, and that the rings were even thinner than the most outrageous claims made from the ground, averaging just 10 meters. To put that in perspective, if the rings were as wide as the world's tallest building is tall, then they would be as thick as a sheet of paper. It is now believed that the reason for the excessive thinness is that thicker rings would have particles with more inclined orbits, which would have more energy than particles moving in a flat plane. But as particles collide with one another, they lose energy, and so their orbits tend to spread out and flatten. The Voyager fleet unearthed a plethora of new moons, many of which played roles in sculpting the rings. A number of new divisions, named the Encke and Keeler divisions, were found to be kept clear by tiny moons orbiting within them, one of which, Pan, went unnoticed in the images for a decade, and several more of which were not observed until the Cassini mission 20 years later. Similarly to Mimas and the Cassini division, 2 small moons in co-orbit with one another, Janus and Epimetheus, act in resonance with the outer rim of the A ring, and maintain the ring's sharply defined edge. Perhaps the most elegant discovery of the Voyager era was just how the improbable thread-like F ring could maintain itself over millions of years. The F ring is extremely dynamic, changing over the course of hours. What could keep it from flying apart? The answer appeared to solve itself when the Voyager team noticed 2 moons in an orbital dance around the ring. The gravity of these moons, later named Prometheus and Pandora, seem to act in tandem to keep the particles of the ring in line, the outer one pushing them inward, the inner pushing them outward. This led the Voyager team to grant them the rather poetic moniker Shepherd Moons. Unfortunately, later observations by Cassini would reveal that the truth is a lot messier and less elegant. In fact, Pandora plays no role in shepherding the F-ring at all, and Prometheus is a worse shepherd than that angry dog in Babe, yanking material out of the ring and rendering it the jagged, twisted mess that we see. But such is the orbit of Prometheus that every shove it gives the F-ring exactly cancels out the previous shove, meaning the ring always stays in place. One of the questions raised by the Voyager mission was why the main rings of Saturn, in particular the B ring, so resemble a vinyl record. The grooves are not individual rings, but built into the structure of the ring itself. A possible answer to the question emerged from the study of galaxies. For many years, it had been assumed the spiral arms seen in most galaxies were individual, physical structures. But in the 1960s, a new model was proposed that suggested that the rings were a phenomenon known as a standing wave. A standing wave is analogous to a traffic jam. As cars bunch up, a jam forms and persists, even if, over time, it may contain none of the same cars. In galaxies, a strong gravitational force, say by a large concentration of mass or a nearby galaxy, can create such a disruption. Because stars near the outer rims of galaxies travel more slowly than the stars near the center, any such disruption will eventually form into a spiral. In the 1970s, a number of dynamic physicists calculated that a similar process could be creating the waves in the rings of Saturn, triggered by orbital resonances with nearby satellites like Janus. Studies of years of Cassini data have pretty much confirmed that this is indeed what is happening. One of the strangest discoveries of the Voyager mission were ghostly shadow structures nicknamed spokes, whose rotation around the planet appeared to have no relation to the rings. The mystery piqued the curiosity of a graduate student named Carolyn Porco, who decided to make solving it the subject of her graduate thesis. Porco noted that each of the Voyager images was time-stamped, and when arranged in a sequence, the spokes showed that they did not come and go at random, but were in fact tied to the rotation of Saturn's magnetic field. The precise cause of the spokes is unknown to this day, though the leading hypothesis is that the magnetic field captures and carries ionized dust particles from the rings. Porco doubtless didn't realize it at the time, but her graduate thesis would mark the beginning of a lifelong relationship with Saturn. 10 years later, she was appointed head of the Cassini mission's imaging team. Perhaps the single greatest discovery of the Cassini probe regarding the rings of Saturn is that, rather than a staid procession of marching particles, they were a wild river of frozen water, their particles subject to the same waves, eddies, vortices, and ripples as any terrestrial cataract. The particles in Saturn's rings exist in a constant roiling cascade as the forces of self-gravity and tidal shear compete to pull them together and then tear them apart. The rings are carved out by tiny moonlets, whose gravity forms the many gaps in their structure as they stampede through them, leaving ripples in their wake. On the occasions when the tiny 8-kilometer moon Daphnis, which maintains the Keeler gap in the A-ring, rises slightly above the plane of the ring, it raises waves in the 10-meter thick ring 1 kilometer high. That is the equivalent of a 200-foot wave rising out of a paddling pool. The rings were found to be dotted with whirlpool-like features dubbed propellers, attempts by invisible moonlets to form their own gaps in the rings, only to be thwarted by the ring's surrounding mass. Because particles closer to Saturn orbit more quickly than those farther away, much like a mini-spiral galaxy, these disturbances form propeller-like arms. Speculation had bubbled for decades over whether Saturn's rings were warped, like a record left too long in the sun. Cassini showed that they were not, but that they were far more uneven than they first appeared, containing clumps the size of mountains. Cassini also found that the rings rained water particles onto the surface of Saturn in quantities sufficient enough to dent its ionosphere. One mystery that Cassini very quickly resolved was the origin of the ghostly E-ring, which, appropriately, is created by cryovolcanic eruptions on the moon Enceladus. The G-ring is maintained by a tiny moon only half a kilometer wide, called Aegeon. Cassini found several other faint rings associated with moons, in particular a tenuous outer ring centered on the captured comet Phoebe. Cassini also found that the maintenance of Saturn's A-ring requires a lot more than one moon. Dynamic physicists have calculated that in order to prevent the A-ring from flattening out and disappearing, as many as 7 of Saturn's moons have to work in concert. creating density waves that slow the ring particles' momentum, a momentary glimpse into the astounding complexity of the Saturnian system. One phenomenon Cassini did not initially see were the spokes, which failed to reappear until 3 years after its arrival. This suggested that they may be a seasonal phenomenon, tied to the arrival of Saturn's equinox. Since the rings were discovered, one question has perplexed more than any other. How did they form, and perhaps more importantly, how long will they last? It's clear that forces are at work that, if left unchecked, will ultimately destroy Saturn's rings. The strange process that creates the spokes is also clearly removing material and sending it into Saturn's ionosphere, as is the recently discovered ring rain. And yet, the rings, by all appearances, are baby fresh. The particles that make up Saturn's rings are 99.9% pure water, pure enough to put in a glass. They are so bright that they bathe the planet in ring shine, illuminating even its night side. Some have argued that this means that the rings cannot be more than a few 100 million years old, and that we shouldn't expect them to be around for longer than that. However, others have argued that the rings could be constantly renewed and replenished by cometary impacts, and so their pristine appearance is not an indication of their age. But the most recent studies suggest that Saturn's rings may indeed be a temporary adornment. Results from the Cassini mission have finally managed to pin down the rings' mass, and, at less than half the mass of Mimas, suggest that they could not have formed with Saturn, or they would have been far more massive. Instead, they appear to have been the result of a freak occurrence, such as a comet or a small moon passing through Saturn's Roche limit. This does not rule out an ancient origin for the rings, but studies by Cassini have shown that the number of micrometeorites falling into the rings is far too low to account for their current pristine condition, unless they are only a few 100 million years old. Despite the close attentions of Cassini, much about Saturn's rings, in particular many of the gaps, remains unexplained. However, with the human race's eye turned toward its more inviting moons, it looks like Saturn's rings will keep their mysteries to themselves for the foreseeable future. And thus ends my second attempt to cover the Saturnian system. Can you believe I originally thought I could do it in one video? Apologies for the lack of alien stuff, but I don't know if anyone's even considered whether the rings of Saturn could be habitable. In my next video on the series, I definitely will be looking at the smaller moons of Saturn, and there definitely will be alien stuff.